Hi there! Today we'll show you on how to determine the arc length that corresponds to a central angle, presented by Group 1 of Grade 11 Blessed William of Tirry. I am Alegrado.
I'm Jonas Kim P, Arcipe.
I am Julianne Mariah Auza.
I am Phoena and Carredo.
I am Samantha Akeisha S.
After a discussion, you will be able to understand the different formulas for solving for the arc length, the parts of a circle that are crucial in solving the arc length, and how we can apply and understand these problems in real-life scenarios. Now let's begin.
To understand the concept of arcs, we must first understand what is a circle. A circle is a round-shaped figure that has no corners or edges. We see circles in our everyday lives, such as the wheels of a car, the clock on the wall, and the beach ball on the beach.
Now, let's take this time to understand the different crucial parts of the circle when it comes to determining the arc length based on a central angle. These are some key terms to further understand our topic. First, a center. The center of a circle is defined as the point in the middle of the circle. The points that makes up the curve are all equidistant from the center point. Next is radius. The radius of a circle is defined as the distance from the center point to any endpoint of the circle. And lastly, the central angle. A central angle is an angle whose apex is in the center of a circle, and whose legs are rather intersecting the circle in two distinct points, A and B, which has a place value called angle theta.
Through removing a part of the boundary of the circle, we get what we call an arc. It is any curve joining two points together, point A and point B. An arc length is the distance along a portion of the circumference of any circle or curve. It is any distance along the curved line that makes up the arc. Now, the question is, how do we determine the arc length?
Consider a circle divided into two equal semicircles. Let's assume that its radius is r. What is the length of this arc marked in blue? We can say that it covers half of the boundary. Let's write the length of the arc under the circle, so its length will be equal to 1/2 multiplied by 2 pi r. This tells us that it's part of the circumference. Now, let's consider a circle divided into 4 equal parts. What will be the length of this blue arc? Since the circle is divided into 4 equal parts, the circumference will also be divided into 4 equal parts. So the length of the arc will be 1/4 of the circumference. The length of the first arc is 1/2 of the circumference, and the length of the second arc is 1/4 the circumference. Now look at the third circle and consider a part of the area of the circle. What will be the length of the shaded part of the arc? It is unclear as we cannot guess the length just by looking at the figure. So there has to be something that defines the length of the arc. The length of the arc is directly proportional to the angle that corresponds to the angle at the center, which is called the central angle. The first arc obtains an angle of 180 degrees at the center. The entire circumference has an angle of 360 degrees at the center. So the length of the arc is given by 180 by 360 multiplied by 2 pi r. In simple words, we can say that the arc has covered 180 degrees of the total 360 degrees, which is then simplified into 1/2 multiplied by 2 pi r. Let's understand further with the next circle. The arc has a central angle of 90 degrees at the center, so its length would be 90 by 360 multiplied by 2 pi r. Now, what will be the length of this arc if the angle has a 30 degree central angle? It will be 30 by 360 multiplied by 2 pi r. We can say that the angle subtended by the arc at the center is a part of the angle covered by the entire circle, which is 360 degrees. Through this understanding, we can generalize if the angle is subtended by the arc at the center, which is the central angle is theta. then the length of the arc is theta divided by 360 multiplied by 2 pi r.
The length of an arc can be calculated using different formulas that correspond to the unit of the central angle of the arc. The measurements of the central angle can be given in degrees or radians, and accordingly, we calculate the arc length of a circle. There is the degree formula which was explained earlier on. It is the length equals theta divided by 360 multiplied by 2 pi r, where r is the radius of the circle and theta is the corresponding central angle in degrees. The second formula is the radian formula. It is length equals r multiplied by theta, where r is the radius of the circle and theta is the corresponding central angle in radians.
Let us solve for our first example. What is the length S of the given arc below? It states that if the radius of a circle is 5 inches and the measure of the arc is 90 degrees, what is the length of the arc? Let us use the degree formula, which is length equals theta divided by 360 degrees multiplied by 2 pi r. Substitute theta into degrees and r into 5. The solution now becomes length equals 90 all over 360 multiplied by 2 pi multiplied by 5. Reduce 90 all over 360 into 1/4. Multiply 2 with 5 to get 10 pi. Then, solve for all which equates to 2.5 pi, or approximately equal to 7.85 inches. To finalize, the length of the arc is approximately 7.85 inches with radius of 5 inches and a central angle of 90 degrees.
Moving on to our second example, what is the length S of the given arc below? It states that if the radius of a circle is 18 meters and the measure of the arc is 30 degrees, what is the length of the arc? Let's use the degree formula again, which is length equals theta divided by 360 degrees multiplied by 2 pi r. Substitute theta into 30 degrees and r into 18 as stated in the problem. The solution now becomes length equals 30 all over 360 multiplied by 2 pi multiplied by 18. Reduce 30 all over 360 into 1/12. Multiply 2 with 5 to get 36 pi. Then, solve for all which equates to 3 pi, or approximately equal to 9.42 meters. Finalize, the length of the arc is approximately 9.42 meters, with the radius of 18 meters and a central angle of 30 degrees.
Our first two examples were simple to understand. Now let us understand deeper by using the radian formula. The question is, what is the length S of the given arc below? It states that if the radius of a circle is 3 meters and the measure of the arc is 30 degrees, what is the length of the arc? Using the radian formula, which is length equals r multiplied by theta, we substitute r with 3 as stated with the problem. Now, as we are using the radian formula, we need to convert 30 degrees into radians. We do this by multiplying 30 degrees by pi over 180, equating to pi over 6 as its radian form. We then multiply 3 by pi over 6 to get pi over 2 meters. However, we can't say pi over 2 meters as our final answer. We need to divide it to get the approximate value of 1.57. To conclude, the length of the arc is approximately equal to 1.57 meters with a radius of 3 meters and a central angle of 30 degrees. Do take note that regardless of the problem given, we're able to use either formula by incorporating the conversion formula of degrees and radians. Use the formula in which you find is easiest for you by simply converting radians to degrees or vice versa to correlate with your chosen formula.
For our last example, let's keep using the radian formula to practice our skills. What is the length of the given arc below? A cyclist bought his bike to a bike mechanic. While looking at this bike, he noticed that one of the wheels only has 11 spokes. Recalling what he learned in his pre-calculus class, he realizes that each of these spokes represents a sector. He deduced that each of the wheel had a radius of 16 inches and that of the spoke had a central angle of 120 degrees. By using the radian formula once again, length equals r multiplied by theta, we substitute 16 inches with r as stated in the given. Then, convert 120 degrees into radian by multiplying 120 by pi over 80, which equates to pi over 3. We then multiply 16 by 2 pi over 3 to get 32 pi all over 2 and get the approximate value of 33.51 inches. To conclude, the length of the arc of each spoke is approximately equal to 33.51 inches with a radius of 16 inches and the central angle of 120 degrees. That is all for the last example, and thank you for listening.
We hope you learned much as you listen to our discussion. As said by Albert Einstein, pure mathematics is, in its way, the poetry of logical ideas. Once again, we are Group 1 of Grade 11 Blessed William of Tirry. And I am Alan Derek Alegrado, who is the leader, PowerPoint maker, editor, and discuss the process on how to calculate the arc length of this discussion.
I am Jonas Kim P, Arcipe, and my role is portraying crucial parts of the circle and discussing the first example of this discussion.
I am Julianne Mariah Auza, and my role is discussing the formulas to get the arc length and for answering the third example for this discussion.
I am Phoena M. Carredo.
And I am Samantha Akeisha S, and my role is discussing the real-life application of a circle and answering the fourth example of this discussion.
Once again, we are Group 1. Thank you and adelante.